this topic, new topic, lecture friction. You know, if you have two objects, like this one, they have a rough surface. So some of them, they have a peak and valley, right? And then what happens, they make some resistance against motion, against movement, right? Um, so that resisting requires, some force to overcome. So let's say you have this object on top of this one. It's not going to be, if you don't have friction, it's going to be free to move. You apply a little amount of force, it's going to move, right? But you have this peak and valley, it's going to make some friction, some resisting. It's called, resisting force, right? Um, but how can we calculate? How can we find, how much force I need to apply to that, object in order to move it? There are, there is a equation. There is this chart. They say if your part is static, it's not moving yet, you get, static friction. It's called mu s. So this mu s is only valid for a part that is in a static mode, no motion. But once a part is moving in a motion, then we have a different, kinetic friction, mu, k. So it's going to be less than the static mode, right? So it means, when you have less friction, less coefficient, as you see, the force that requires to move the part will be less. This is the coefficient. This is the amount of, reacting force, acting force, and this is the force it requires to move the part. So the ratio of the maximum frictional resistance, F, this is called, frictional resistance. How much force that, surface is going to produce. It's a normal force. How much force is going to be applied from this surface to this surface? We call it normal force. Okay? So that's normal force. And then friction force is going to be horizontal. The relation between them, frictional force and the normal force coming from this part, it's called, mu s. This is the static one. So F can be maximum frictional resistance. Okay, let's say, we have an object like this one. And then it has a weight, right? W. What is the normal force? So in order to keep this part, in a static mode, stationary, we need a perpendicular force to keep it stationary in that location, Fy0, right? W minus, let's say we're going to use that, this is positive. So W is going down, and then perpendicular force, or the normal force, let's call it normal force, N is going to be on the opposite, right? So in this scenario, my N will be W, because this is horizontal. I have only one force, going in this direction. N is always, we need N for calculating, friction force. And this is always perpendicular to the surface. If you have, this is not good. If you have, object like the, inclined surface, right? Alpha, your part is in this location, right? So then your W will be always down, perpendicular to the ground, right? This is W. My N in that way, in that scenario, it's not going to be W. I said, N is going to be always perpendicular to the surface. So that N will be different from this one, this scenario, because we have inclined surface. We're going to calculate it later. Okay, so mu S, friction, coefficient, that changes depending on the surface of the material, what material you're dealing with, and every material in dry condition, they have different number. In static steel and steel, they have this number. Kinetic, always lower number, right? Kinetic in when the parts are moving, so you need to apply less amount of force. So this is for steel, and let's say wood are going to be less than steel. Aluminum on steel, 0.4. So force acting on a block. Let's say, we have this block. So the block has a weight, correct? And then we are pulling it, this direction, on the right direction. The normal reaction to keep this part, here in this situation, it's called, N, and always upward, to the surface. So this is, we have a friction force, right? If you are pulling it, if you are pulling this one this direction, the resistance, or friction resisting, force is going to be opposite. Why? Because, friction is going to cancel that force. It's going to be against, this pulling effect, right? So in this case, this is going to be opposite, right? So this is going this direction, and we have N, normal force. And these two forces, you remember when you have two forces, you can get a resultant, right? Resultant of those two forces. Two perpendicular force, the resultant can be this equation, N plus, what is it? F, this is friction. You can also find, theta, the angle of that, R, which is inverse tangent of opposite. Since this one, we are looking at, we are looking at this angle, the opposite is going to be this, right? F. Adjacent will be N. Opposite is F and N. Okay, so that is when we have the part on the flat surface. If you can leave it on that, yeah. Thank you. So when we have inclined surface like this one, so those forces will be different, right? Let's say we are, so this one, we don't have that P. What was the P in the previous example? Pulling, right? So we don't have the pulling force. What do we have? We have the friction force. We have that weight. So what's happening here? The weight is going to push the part down, right? And then, the friction, what is it the friction is going to do? So it's going to resist. So in this scenario, this resistance, this friction is going to be in this direction because we have one force, applying and trying to bring the part now down. Yes.
Student, you're missing on the paper.
There was a couple missing.
Yeah, two.
I had two.
Okay.
Yeah. I'll see you later. Yeah. So the friction is always on the surface. You do not draw a friction this way, this way. It's going to be always horizontal to the surface, parallel to the surface. And then we have this normal force, this one, then you can find R. Okay, so in this scenario, what is the if you, in order to find the normal force, it's not going to be like this. It's not going to be easy, something like that. You can decompose the weight into X and Y. How? We can look, normally we have this coordinate, right? This is, Y and X. In this surface, instead of, that standard coordinate, this is not going away. I can use, a coordinate. I'm going to tilt it. I'm going to rotate it. Then this is my X. This is my Y. I just tilted, how much? It depends, what is your angle. Let's say. So I just tilted, by that amount of angle. So I put my X and a Y, something like that. So this is going to be my horizontal line. This is going to be my vertical line. Okay. So my W, my box is here. Weight is always perpendicular, right? Now, so this is my Y, right? So this is my X. And you tell me, what is this angle? Let's say, I'm going to give you a number, and so it might be easier. So I'm looking for this angle. 30 degree. This is, 90, right? So this is going to be, 60. This is, perpendicular, so this will be 30, right? Okay. So this one, I'm going to find, force in this direction and the force in the perpendicular direction. Why? Because of the friction force. We need, to find the normal force. So what is this force? You can use this one. You can use this force, this angle, whichever you feel comfortable. But most of the time, we use this one. So whenever you have this angle, you can say my horizontal force will be W, whatever W is, times So this is going to be sine 30. Yes, that's right. And this one will be W cosine 30. So here I'm going to calculate the n, right? N for the flat, what was it? For the flat scenario, W n. In the flat scenario, it was N was W, right? We had only one force. So these two have to cancel each other. Now look at this one. So we are looking at this coordinate, not this coordinate anymore. So look at this coordinate. What are those forces in y direction? W. Huh? Yes. No, W. No, we are looking at the y value. So this one. W cosine 30, and it should be negative, right? Everyone agree with that? And what else do we have? Perpendicular force to the surface, N, right? N plus N, 0. So N in the inclined surface will be W cosine 30. You know how I get this one? I just add plus W cosine 30 in both sides, W cosine 30. So this is going to be canceled by this. I will have only this portion, right? N is going to be in the inclined surface. N is in W times cosine 30. And this is my force for pushing, W, the block going, this slope. So then, what is the friction force? Friction force. F mu s, if they say the part is in a static mode, mu s times n, right? Okay, and then here you can establish the other equation, f of x. We're going to be using this f of x, f of y all the time. F of x, and again use this one. What are the forces in f of x? W, yes, going down. So it's negative, right? Because we showed, this is plus, so this is going to be going that way. W sine 30. And then what is my force in the other direction? Because, I'm thinking that, my block, is going to go down. My friction force is going to be against it, right? So my F will be like that, plus F. So it should be 0. So in order to keep, the part stationary in that situation, so I can add, W sine 30 here. Yeah, here the same thing. W sine 30. What I will have is this one is gone by this. I will have W sine 30. My friction force is going to be, has to be this much, my friction force. Okay. Yes, this is all we use. But for this problem, the forces are concurrent. We use fx, fx, fy. F is this one. If you may have some condition, the forces are not concurrent, then you can use this one. Like thrust, you remember joint, in the joint method, we could not use this one because all the forces were concurrent. They were going in one point. Okay. I have a question for you. Look, we have this weight, which can be, let's say, it has, if they say, 10 kg, what do? You have to convert it to Newton, right? Whatever it is, 10 times 981, that is N, right? So, which is 98.1 Newton, right? This one has this much force, weight. And then I'm going to calculate my friction force, amount of force that I can, I need to, push it, move it. What is it? F, that equation, mu s times N. Okay? So in this case, what is N? N is going to be exactly this number, right? We said for horizontal, we're going to use this equation. For inclined, it is a little different. So F is, let's say it is a steel to a steel, what we have different number. We're going to use a steel to a steel, and we use the lower number. 0.4 times 98.1. Okay, so this is my friction force. How much is going to be? Let's say 50. No, this is not a right number. 50. So what is it? That means, I need to apply 50, P has to be 50 in order to move it. Okay? So F will be in this direction. Let's look at this problem.
Hey, Professor, is all that final cumulative, or is it just going to be on the
Comprehensive, all together, all parts, all chapters. So we have a 400 block. It already gave you the force, right? Then you don't need to convert it. So it is on horizontal floor. The coefficient of static. Remember, it says static, not kinematic or kinetic. It is mu s, and between the block and floor is about 0.4, right? That is unitless. It doesn't have unit. Calculate the P required to cause motion to impend, start to move. Okay, impend means start to move. The force applied is going to be if the force is horizontally. If this force is horizontally, okay? So what do? We need, to use, fx, and this is 0, and f of y. Initially, we need f of y. Why? Because in that we can find, n, right? Why we need n? Because we need it for friction force. Correct? So let's go with the Fy equation. Fy 0. So my W is 400, minus going down. And then I have N going up, which is 0. Has to be 0, right? So my N is 400. Okay, I can go to my other equation, Fx0. In Fx, I have P going to the positive direction. What else? I have F minus F going to the left. That's all, right? 0, I can write it. What is F? This equation, right? Mu S times N, 0. What is mu S? 0.4, right? Times N, 400, 0. So my P will be this much. The amount of force I need to move this part. So I have to get to that point in order to move the parts. So, okay. So this is for the first scenario when the part, the force is applied horizontally. But, I had one, good tools to learn, friction topic. Let me, bring it here. This one. This is a very cool animation. It shows you how much friction, a part may have. Let's say this is a box, right? And it has a weight, correct? So if you don't apply any force, what's happening? Let me reset it. So if I apply a load, so the person is applying, this much force, 61, right? And summation of forces is 0. Why? Because there is a friction is going to be against that load, and the friction, it's going to keep going up until a certain point where it's not going to be, because you remember the maximum force, maximum friction force, it will be a function of the weight and that friction. So the friction, for at this point, I think it's going to be about 0.3, 0.2. I don't know how much friction is this. This is going to be average. Okay, so let's see if I add increased force, what's going to happen? So my friction force is still going up. My friction force is still going up. Still, there is no motion in this direction. My applied force is this, my friction force is that. So this is going to go up until I reach the maximum force, which is going to be for this one, the maximum force, it's mu F times N, right? So, so I now it's moving. So you see, the summation. This is the amount of force I am applying. This is the maximum, force. The friction is producing. So you have to subtract it from here. So you get, some force. You remember when you have a force in one direction, your part is not going to be stationary anymore. So the part is moving, it is speeding up, right? If I bring my, if I make it in a way that in the force, the summation is going to be 0, then my speed is going to be 0, because then I don't have acceleration. Remember that equation from the beginning? F times, no. What was the equation? F m a, right? So because we got acceleration, we get we got the speed. Oops, something happened. My friction, my load. So I'm gonna make a summation of force 0. Then my speed is gonna be 0. Now it goes with the same constant speed. It's gonna be in equilibrium. It's gonna stay in whatever situation it is. So this is in equilibrium. There is no force, but the part is gonna go with the same speed. Okay, so that was one thing. Another experiment we can do. Yeah, we can do more stuff with this one. You see, if I so the friction force increased because I added more load in there, right? There was another one. So look, when I remove the force, it's gonna, friction is gonna be always against, the motion. Okay,